Alright, so latent growth curve modeling. Before we get into the data set and syntax, I want to talk a little bit about the conceptual nature of how we typically tend to approach change over time and how latent growth curve modeling approaches change over time. Typically, we tend to piecemeal our understanding of change over time using a repeated measures ANOVA approach, where we essentially compare individual time points to each other in a pair comparison sense. So time 1 to time 2, time 2 to time 3, time 3 to time 4, time 4 to time 5, and so on. So essentially what we're doing here is we're looking at individuals within a single time point and how they compare to with individuals compare to individuals within a single time point here, here, and here. But what latent growth curve modeling does is essentially look at, we're essentially looking over time points, so over time within individuals. So rather than looking at a single time point and seeing how people differ, we are looking over time to see how people differ. So we're becoming less interested in the individual data points and more interested in the overall trend line for that person's data. So this would be an example of one person, but as we see, what we end up with is multiple trend lines such that each individual has their own trajectory, their own trend line. That's where we get the growth curve or growth trajectory in latent growth curve modeling. But what that allows us to do then is then average those growth curves or those trend lines and get a representative average of for the sample in terms of how they vary as a sample over time with respect to some level of a latent construct, which again in this case is antisocial behavior, as we can see here in these two graphs. In my data set has 4 time points, and so we have 4 associated antisocial behavior measures, and this data set was adapted so it doesn't quite fit, but it'll fit with the context of this example. Forgot a point. There are essentially three pieces of information that we can gain from an understanding of the trend line. The first being the intercept. So that is, people have different starting points in their level of the underlying construct, i.e. their intercepts. But people also can vary in their slopes or the rate of change over time with respect to our latent construct. The other thing, or the other piece of information that we can glean from this is our error, our residual variance with respect to our trend line. So for example, we got the trend line here, the difference between this point and the trend line, that's our residual. So anyway, those are 3 pieces of information that we can glean from a trend line of this sort, and this will become more important when we start talking about the model constraints as we move through the syntax. All right, so with our first model, it's important to note that in the latent growth curve modeling framework, we're starting with the most restrictive model and moving to the least restrictive model. So we should see improvement in fit as we go through each of our models. So, and again, the 3 pieces of information that we're going to be constraining are the intercept, the slope, and the residual values. So with our first model, this is our intercept-only model. And it's our intercept-only model because we haven't included a slope yet. And our intercept-only model basically approximates, or doubles as our baseline model, because what we're looking at is the change, the latent growth curve with respect to our underlying construct. So the change that we're seeing within people, is that change significantly different than no change at all? And because we don't have a slope, we essentially have a flat line with a restricted intercept. So basically what we're saying is that an average score, or an average level of antisocial behavior is best for all time points. So in other words, we have a flat line. And we're comparing that again, so no change to change, in the sense that we're going to start relieving or removing some of these restrictions to see how well each model fits our data. All right, so with our first model, the first thing we're going to do is establish our latent intercept. So this is the time, basically the time intercept, where we are regressing our I, this is our intercept, onto each time point, respective time point. And we're multiplying each time point by 1 so that we get mean estimations for each individual time point. And then we are using this bit of code here. We are then constraining the intercept variances to 0. And then we are restricting our residual variances. Our residuals are forced to be the same. And we do this by multiplying each residual times itself. And then we're going to regress the I component, our latent intercept, onto each of our antisocial predictors. All right. So now we're going to look at model fit, and I just included the table here just so it's easier for us to compare. So ideally, because this model has all the constraints, we would expect this model to be really sucky with respect to how well it assesses or approximates intra-individual change. So we see our RIMSA is not too great. Our SERMR isn't either, and we don't even have a reasonable CFI value. But that's good. That's what we'd expect. Because what this is telling us is that no change, or change, is significantly different than no change in our data set. Now we're going to, with model 2, let's look at these, right? Talk about where some of this other information is here with respect to our output. So we've already had our residuals restricted to 1, or our mean estimates restricted to 1. That's what multiplying them by 1 did for us. Then we restricted our variances, so our residuals are all the same value, and our intercept is restricted to 0. Great. So we've effectively restricted all of the pieces of information that I mentioned before: our intercept, our slope, and the residuals. So yeah, so we have the same residuals across time points. We have an intercept mean, and this intercept mean is here, which is 10.132, and then we have a intercept variance of 0, which is what we set, which is great. Now let's move to model 2, which I will, yeah, there we go. All right, so Model 2. The difference between Model 1 and Model 2 is that we are now allowing the intercept to vary. So in other words, we've removed the constraint of the intercept equaling 0. So now we've allowed the intercept to vary. Specifically, we've allowed our variances, our intercept variance to be greater than 0. So now, rather than starting at a single time point like here, now we're taking into account that people are at different levels of antisocial behavior, so they start at different time points. But this intercept is random. So in other words, we're saying, is allowing intercepts to vary randomly significantly different than allowing everything to be constrained? So let's take a look at our fit indices here. Again, so we do see a smaller RIMSA, which is what we'd start to expect. We still see a poor SURMR and a poor CFI value, but we're starting to see decreases in some of these values, indicating better fit as we move along. All right, so now on to Model 3. Model 3 is essentially adding the slope, adding in the slope. But similarly, as with Model 2 and how we had a random intercept, now we're adding in a random slope. So everybody is changing in different ways, essentially, is what we're saying. And so this code here with line 60 is setting the average slope to 0, and this line here is basically having our slope, or it's basically setting up our uncorrelated slope, uncorrelated intercept. In other words, everything is random. The intercept is random and the slope is random. Is that variation? So now we're looking at, is that variation while still controlling for the change in residuals, the difference in residuals. So we're keeping them constrained. Is allowing the intercept and slope to randomly vary significantly different than the previous two models. And so now we'll see that we're seeing improvement in our RIMSA. SURMR is getting worse, but so we're starting to see some improvement in our fit indices. These other two will hopefully catch up as we move from Model 4 or 3 to 4 and 4 to 5. But again, we're seeing the differences in what we allow to, or what we allow to be constrained and what we allow to be free and varying. So from Model 2 to Model 3, we see that our mean is the same, but because we allowed our mean to vary, we see a different intercept mean. And we still don't have a slope mean because we haven't included a slope, but we've included slope variance, that random slope variance. Great. And our residuals went down because now we're accounting for the removal of our constraints, because we're allowing our intercept to vary and we're allowing our slope to vary. All right, so now on to Model 4. Now with Model 4, we are allowing both the intercept and the slope to vary but this time the slope isn't a random variance. So in other words, now we have a slope and intercept that are going to start fitting the data a little bit better. But we're going to leave the constraint on the residuals. Let's see if that helps. So now we're looking at model 4. We have an improvement in our RIMSA, we have an improvement in our SERMR, and our CFI value is starting to get a little bit closer to our cutoff value. And again, so our CFI values greater than or equal to 0.95, or acceptable at greater than or equal to 0.90, RIMSA less than 0.06, and SERMR less than 0.07. These are just some general guidelines for these fit indices that I got from Hugh and Bentler in 1999. All right, so now we remove the restrictions for the slope and the intercept, and we're starting to see that people varying in their level of antisocial behavior. So employees varying in their level of antisocial behavior and their rate of change with respect to their level of antisocial behavior is significantly different than no change at all, or change based on variance in an intercept and variance in the slope. So now, with our last model, we're looking at our free model. So this is our unconstrained model. So now we're seeing that once we remove all the constraints, how well does our model fit? And is that model significantly different than our previous models? So the one, specifically the one before. And we see that our CFI value starts to approximate 0.90. Our SERMR is 0.07, and our RIMSA is 0.2. So roughly speaking, this is not the greatest fit for the data, but it is approaching greater fit indices as we've removed the restrictions, essentially. And we're starting to see some change. In other words, we're starting to see the evidence of growth as we remove our restrictions. So the difference between 0.56 and 0.752 are comparative fit index. We're seeing a change of 0.104 from model 4 to model 5. And we also see that our intercept variance is starting to decrease. The same with our slope variance. So ideally, what we're seeing is that from in Model 5, what we're seeing is that on average, the results indicate that employees are exhibiting a growth of 2.1 points. So mean slope 2.1 points over time in antisocial behavior, specifically a decrease, so it's a decreasing trajectory, indicating that as tenure increases, as employees increase in tenure, they also, of course, they have a corresponding decrease or show a corresponding decrease in antisocial behavior. Oh, and we also have our covariances there. So we have a covariant intercept, covariant slope. All right. So that is essentially conducting a latent growth curve model in R. Cheers.